Hello and welcome to a chapter on structured cabling and networking elements. So in this chapter, we're going to talk about the commercialized building, how to cable um, um, an infrastructure within a commercial building, and what are the standards, the protocols that go beyond that, the naming convention, we'll talk about that. We'll get into the Ethernet also and the Ethernet frame. We'll talk about the Ethernet frame and the labels that are on the Ethernet frame and troubleshoot network devices. How do you set up a networking topology and be able to draw the physical topology of a network and labeling it so that knowing how everything is connected logically and physically, so that if you need to troubleshoot it, it'll be much quicker and much easier to do that. All right, so the network equipment in a commercial building, it is the industry that really regulates, no, not necessarily regulates, that sets the standards for the cabling is the Telecommunication Industry Association and the Electronic Industry Association. Together, they set the standards for the cabling for all types of cable, the unshielded twisted pair cables, the coax cable, and the fiber optic cables. They set the standards on the pins, which pin is to transmit, which pin is supposed to receive, which pins is going to be grounded, and so on. So this way, once you follow that standards, anybody can make up the stand. Anybody can really make up a cable according to the standard. As when they connect it to their NIC, they'll be able to transmit and receive just like any other cable that is being used. Anyone can really make up a cable as long as they adhere to the standards of the TIA/EIA standards. All right. So when we are talking about a commercial buildings, you're going to have the main distributed facility, the MDF. This is the main building where everything comes from outside. It comes to the main MDF. This is the demarcation point, the demarc point. So please write this down. I don't know if we mentioned it before or not, but the demarc point is where the service provider liability begins, and where the customer premises equipment, the CPE, that's everything inside the building, that's your responsibility. So the demarc point is where the service provider liability begins. In other words, if anything happens outside the demarc point, that's the responsibility of the service provider. Now, once we get into the main distribution facility or frame, they call it, it can send data to intermediate IDFs, intermediate distributed facilities. So you could have a building somewhere and it's connected to the MDF, and another building, another IDF connected to the building, to the main DF. But all the buildings, all the IDFs connect directly to the main distributing frame in this case. Right? You could have a work area too if you want within this building, building A, but this is where the network room, the connection to the outside world. Okay. So inside the building, the entrance facility, that's where the demarcation point. MDF is the main distribution frame or facility. This is where the connection, that's where the demarc point is. This is where all the connection comes from the outside. IDF is the intermediate distribution frame or facility. This is like a branch building that connects to the MDF. Horizontal wiring is the wiring that connects the PCs to the patch panel or the workstations within a building. And the backbone is the connection between the MDF and the IDF. And the work area is where all the workstations are. So for example, here's the work area. When you connect your PC all the way to this patch panel, this is called the horizontal wiring. When you connect from here to the distribution facility outside, here, the main distribution facility could be on the first floor, could be physically in another building. That's the vertical cross connect. Okay, just to let you know. All right, so when you do a horizontal connection from a workstation all the way to the cross connect right here to the patch. This is the patch panel, right? So what you need is about 3 feet or 10 meters. Connections should not be less than 10 meters. It should be less than 10-meter connection from your desktop to some data jack that's on the wall. So it should be close to you. And then from the data jack all the way, you'll run it either on top of the ceiling or on the floor and all the way to the patch panel. So you patch it on the back, that should be less than 90 meters. And from the patch to the switch or to a router, and then that should be another 10 meters altogether from the workstation all the way to your switch. And from here to the, let's say, to a router should not be greater than 100 meter. That's the maximum distance. All right, so here's the punch down connection. So when a PC comes into the wall outlet, so this is the 10 meters. Goes out in the ceiling throughout the building till it gets to the punch hole. You punch it in, right? And from the patch panel, you can go down to the MDF. So you can connect this to another patch panel. The connection from here, usually in this punch down block, you'll be connected to a switch in here, or a router, or a server. So the connection from here to here, maybe you'll end up right here, and this is where your server would be, right? And by the way, this punch down block doesn't have, you can actually run this. Oops, sorry about that. You don't even, this bench block could be right in here. You don't need it on the wall. So typically this is done right here and you don't need this connection. So what you do is you run this through the wall outside. Typically what's done, unless you have a lot of connection in one building, you connect it here, and then you probably need a repeater to send it out, but it's to make it nice and neat. All right, some cable installation tips to prevent physical layer failures. All right, so please write this down. When you're terminating the twisted pair cable, don't leave more than 1 inch exposed of the cable before termination, because the cable, as we will discuss in a later chapter, they are twisted so you can eliminate electromagnetic interference. Don't unwind them too much, because then the cable will fail. The connection will fail because data will get corrupted just before you even sending it at that end. It's called near end, N-E-X-T. Near, like next, N-E-N-X, and near crosstalk. That's what it's called. And the other one is far end crosstalk. If you unwind the cable before you terminate it, if you unwind it too much, so you want to try to unwind it as much as you want. Do not exceed the cable prescribed bend radius. All right, so in other words, make sure that don't exceed the cable distance. Make sure the total distance till you reach your final destination should be less than, especially for unshielded twisted pair cables, should be less than 100 meters. Use a cable tester to verify that the cable you have continuity, at least continuity. So it sends a signal and it loops it back and tells you if there's connection or not. All right, so, and cinch the cables loosely. Make sure they're, not too tight. Also write down these tips as well. Avoid laying cables across the floor. All right, so make sure if you're going to use if you have no choice but to put them across the floor, make sure you cover them and make sure they are nice and neat. You can go through the ceilings. If you go through the ceilings, by the way, try to avoid fluorescent light, because fluorescent light do emit, keep away from them, emit enough EMI, electromagnetic interference, that will corrupt the data. If you're going to go through the ceiling, make sure they are plenum rated. The cover on the unshielded twisted pair cable is made of material, so for in case of there's fire. Pay attention to grounding requirements. If there's any requirement, make sure your grounding is extremely important. because you don't want, you may lose connections or data could be corrupted, or it could be a hazard. Leave some slack in the cable just in case. Don't make them very, very tight. Give yourself some room just in case you need to cut, change the wire or whatever. So don't try to make it perfect. In fact, do a couple of loops before you connect it. So this way, you'll always have some cable if you need to change the connector at the other end, and you need to, you need some slack, right? Use cable management devices such as cable trays, braided sleeving, or furniture gourmet to make sure everything nice and neat. Use the patch panels to organize the connect, right? The patch panels, just like the ones we have in class, you can download them and connect them using the punch blocks on the punch boards on the back. Also, write these down. You and your network manager should specify standards, the type of cable that you're going to need. Do you need a Cat 5e, the enhanced, Cat 6, Cat 7? It all depends on what type of um, network that you're going to have. If you're going to do gigabit Ethernet, it's preferable that you use Cat 6 or Cat 7 or even maybe fiber. Um, Keep your cable plan documentation accessible, so you should always know how everything is connected, what type of cables and where they are. Label every data jack or port on the patch panel. So when you get to the patch panel, on the top of each panel, you can say this is room 202, this is room 206, this is room 210. So you know where these ports are and who's connected to what. You can use color code cables for different purposes. So for example, if the second floor should be red, the first floor should be yellow, the third floor would be blue, and so on. And update your documentations every time you make changes. That's important. All right. So maintaining device management, maintaining up-to-date records about your network and devices will reduce workload. So you need to know everything about your network, how they are physically connected, what devices connected to what. The physical and logical topology should be written out. So tips for labeling, you could do whatever you want. I mean, you don't have to write this down, but I want you to read it. But it's best to know at the patch panel where each location is, right? Because all the connections from all the whole building from every single room is going to be aggregated into one location at the patch panel. Every port at the patch panel at the cross bar is going to be for a room. So label them so you'll know which room is which and whose connection over there. So you could do that however you like to do it. So typically, for example, this is could be the IT, could be the HR, and so on. So you can label them however you need to, but it's best to do that and use different color codes, different cables that connects to them, so you'll know. Okay. The rack system that we have, they come in onto 19-inch or 23-inch frames, and they're measured in racks units. So like the ones that we have in class. So this is a typical rack unit. So we've put in all our routers in here. You can put the crossbar, as you can see. I don't know if you can see it right here. This is a crossbar that comes in from the ceiling. This is where everybody's connected. You can label the crossbar right here, and then you can go from here, connect it to your routers and switches. So we'll have routers and switches. Here's the back of a rack, right, where all the connections are. And the crossbar, then you can connect them to a router or a switch, right? In a rack system, make sure you leave some room so there's some air ventilations, right? So make sure that you monitor humidity, air ventilations, and temperature, because they do routers, switches, all of these different devices in the network room will generate a tremendous amount of heat, and you want to monitor that. All right, so network attached storage. The NAS is used for fault tolerance. So please write this definition down. What is fault tolerance? It's techniques that allows data storage or other operations to continue in the events of failure or fault of one of its components. So you have some sort of an automatic backup. Um, NAS is really done for storage. So anytime you get into your server, for example, every time you save data to your server, that's immediately backed up to the NAS device. This one is only for storage. It doesn't communicate with anyone. So in case this fails for whatever reason, you can retrieve the data automatically, right? That's a fault tolerance. Uh, you can have a storage area network outside your LAN, right? So a SAN, please write that down, is a network storage devices that communicate directly with each other. There's a whole bunch of storage areas, and this is also for fault tolerance. The connection there, you can use channel, fiber channel, or iSCSI, the small computer system interface for quickness. Most likely you probably want to use the fiber channel for quick connections. Or you can actually, this is like in the cloud. You're putting all your data in the cloud. That's what really the SAN is, the backup. So here's your FC, the fiber optic switch that connects again. That automatically backs up. Now you need this type of setup if you have a tremendous amount of data that needs to back up, and data is constantly changing every day. So like, for example, if you're a big bank, and the data is constantly being updated and the information is extremely important, so you need to constantly back it up, and you always want to have access to it as quickly as possible whenever you need any of the data. So you use SAN, and in case anything goes wrong, your data is safe somewhere else in a different geographic area. Hopefully that's where your SAN would be. All right, so SANs are scalable. If you put your storage area in the cloud, massive storage capability, fast data, fast data access. Almost every cloud service companies, Microsoft, Google, Salesforce, you name them, they give you plenty of SAN storage area for your network, and you just pay a fee to maintain it, and they'll make sure, and it's completely secured pretty much. You don't have to worry about a thing. You just pay a little fee, a monthly fee. I don't know, depending on how much space you need and how much storage you need and how much backup and how often do you access it. All right, power management. I don't know if we talked about that here or not, but to make sure that you have always power, and you have to be aware that there may be blackouts, there may be surge voltage running into your system that will disrupt and you know, will make your servers crash or your switches, and may harm your devices. So all the electrical components have to be one way or another. First of all, they have to be grounded properly, just in case there is a surge of voltage coming into your system. You need to have some UPS system, for example. So write down, these are the power flaws that can damage your equipment. A surge, a surge of voltage in, let's say you have today, not today necessarily, but if it was a cold day outside, you can have a lot of static charges on those transmission lines. And if there is a lightning strikes that hits and one of those transmission line that had static charges, you'll have a whole bunch of extra voltage coming in. The transformer may blow up in your neighborhood, or you may get a big surge of voltage coming into your system, into your building. If you do not have everything properly grounded, you may still have a little bit of voltage coming through, extra, more than what is needed. And what that could do is it can kill your devices, because they're regulated and they are sensitive and they only need DC power. So what you need to do is you want to make sure that you have some sort of a UPS or anything like that. So you got to make sure that you watch for that. Noise is another thing you should be aware of. Write these down, by the way, all of them. Is fluctuation in voltage levels. From your wall outlet, you get between 110 to 120, and sometimes they go up and down. So you got to be aware of that, and that can create electromagnetic interference. Burnouts, if you something, a decrease in voltage, you know, when let's say if you have no voltage or maybe a chip burned out, regulator, right? And because all your electronic devices require DC voltage, if the if your voltage regulator burns out, you may get a surge of electricity coming in, right? Blackout meaning having no power completely. So what do you do then? You need a UPS, an uninterrupted power supply, right? To take care of surge or noise or burnout, you buy those voltage suppressors, right? That you put in so you don't ever connect your electronic devices, your laptops, your servers or your switches directly to the wall outlet, although there is um, a ground and a neutral, but you always want to connect it to a suppressor. Um, this is like the breaker. This, you know what always, because they can actually, if there is a big surge of voltage coming in, the breaker will take care of it. All right, so in case of blackouts, you want to have either a standby UPS, an uninterrupted power supply, or an online power supply. So standby, you can have them either coming in and it provides continuous voltage to the device by switching to the battery when it detects it. This is the most widely used. You connect this to, you have your UPS from the wall outlets, it goes to the UPS, and then from the UPS to your server, for example. If the UPS senses that there is a blackout, immediately within 15 milliseconds, the UPS will keep the voltage going and the server will stay up and running. If now, the UPS is just like a rechargeable battery. It can only last for only a certain amount of time. So you need to go and make sure you bring down your server properly, because the UPS are not meant to keep the server up and running 24/7, because you don't know how long this blackout is going to be, right? So, but it's definitely useful. If you need the service to be running more, you probably would need what do you call it? Generators. But then, generators, they need gas, and if, let's say, gas may be an issue. So depending on where you are, for example, you probably want to get a generator that's connected to your gas line. So this way you'll immediately switch it's going to be a little bit costly, but it will definitely be helpful. For example, if you are in an area where there's hurricanes every once in a while, and they're more frequent than in other areas, you probably want to get a generator that's connected to your gas line. So in case you're disrupted, your generator kicks in and you'll have 24/7 connection. If you have a generator that uses gas with hurricanes or big snowstorms, the gas stations may not have enough gas anyway for you. So that defeats the purpose of having a generator to keep your network up and running. So it all depends on where you are and what kind of backups do you need. Do you need a UPS? Do you need a generator? And what type of generator do you need? Okay. Make sure that you know your PS. Test your UPS every once in a while, because if you have no problems, then make sure that the rechargeable battery is still operational, because you don't want a blackout and all of a sudden the UPS fails. Maybe it looks like that it's working fine, and if it's there for a couple of years, the rechargeable battery may be dead. So every once in a while, periodically test it and make sure it's working properly. All right, so we talked about generators. Okay, environmental and to monitor the environmental and security. So, like I said earlier, inside the network room, you got to make sure that you have the temperature not too high. Humidity should be below 70% and not not too high, and you don't want the place to be too dry. And the whole idea behind humidity is because you don't want any static charges to accumulate. If you have a very dry place, it's easily to get static charges could easily accumulate. Airflow, uh, because if there's no airflow, there's, switches, routers, servers are in there, and usually they are cramped up in a small area that can generate a tremendous amount of heat. And devices, when they get overheated, they start to reboot, and you get a whole bunch of different problems. You don't want to deal with that. So you definitely want to have monitors in a network room to keep an eye on temperature, humidity, and airflows, and to send you an alert in case anything goes wrong, right? All right, let's talk about the network interface cards and specifically the wired NICs Ethernet. The most common type of wired network, if not the only one, is the Ethernet NIC. Now, NIC operates at both the physical and the data link layer. And the two things that really, here's what I want you to write these 4 points for the NIC. This is what really the NIC does. But in addition to that, if you just want a quick answer, the NIC, when you attach a NIC to a device, the NIC will have a name. It's like you given that NIC a physical name, that's the MAC address, and you also given that NIC a communication protocol, in other words, a language. So by having a name and a language, they'll be able to interface, speak with other devices that speak the same language and have the same common, not the same name, but the same type of name, same a different MAC address. Without a NIC, you don't have a name, you don't have a MAC address, and you don't have a communication protocol. You cannot speak with other devices in your LAN. So when you have an Ethernet, for example, if somebody says we have an Ethernet network, that means all the devices in the LAN have the same communication protocol, Ethernet, and they can talk to each other. The communication protocol is called CSMA/CD, Carrier Sense Multiple Access with Collision Detection. That's the language that they speak. That's how they talk to each other. And everyone, like we discussed earlier, everyone will have a unique 48-bit physical address, MAC address. They'll use that to identify who they are inside the LAN. All right, so also a NIC can support something called Power over Ethernet. I want you to know that as well. Power over Ethernet means that your NIC can supply power over the Ethernet cable. You'll use as one of the 8 wires to send power to, most likely it's a voice over IP phone. So if you connect your voice over IP phone to your NIC, you'll have power. The phone will be powered, right? So typically you come from the switch. Also has PoE, can provide, if you can connect directly from the switch as well. The switch can offer power over the Ethernet cable as well. All right, NICs can be integrated as part of the motherboard, motherboard. So in other words, you don't have to install it in those PCI slots. This is the best way to get them because they work the fastest. If you connect them to the PCI slot, usually it's a little bit slower. There's the peripheral component interface. Or you can connect it to your laptop. I don't think these are done anymore, not even this, because I don't know any device now that you can purchase, either a laptop or a workstation or a desktop. They all have integrated NICs. Wireless 802.11 and wired, which is Ethernet typically, which is 802.3 by the way. All right, general tips for installing a NIC, which most likely you will not do. You need to install the hardware and software. If you remember when we talked about ESD, the electrostatic discharge, if you ever need to install a NIC, make sure you discharge yourself, touch a piece of metal if you don't have that wrist strap, and just never ever touch the components on the NIC or on the motherboard, and install it very carefully. Screw everything. Leave the box open, by the way. Try to power it. Make sure everything is installed correctly. Nothing is loose before you close the box. Typically, what I like to do if and when you're installing any type of expansion board in an expansion slot on a desktop. All right. Now, there are several methods for NICs. Well, this is in general communications. Simplex, half duplex, and full duplex. Simplex communication means, please write those three down. The um, three types of transmission methods. Simplex means you are sending data only in one way. It's either you are receiving or sending. There is you don't if you are sending, you cannot receive. For example, like an antenna sending the radio signals, and your radio is receiving. That's in simplex. He only receives, right? Half duplex, it's like you can send and receive, but not at the same time. If you are sending, you cannot receive. You got to wait till you see, just like walkie-talkies, right? You got to press the button while you're talking. While you're sending, you're not receiving. And full duplex is being able to send and receive at the same time. Now, with Ethernet NICs, they come in either full duplex or half duplex. Most Ethernet NICs are half duplex, which means if they are sending, they're not receiving. And if they are receiving, they cannot send. You can get full duplex Ethernets, and you are able to send and receive at the same time. So this is the preferred method, of course. It's a little bit more expensive than the half duplex Ethernets. Auto negotiations. When you take your NIC and you connect it to a switch, here's two things I want you to write down. The auto negotiation. Your NIC will always negotiate with the switch two modes. The speed, how fast the NIC is it 10 megabits per second, 100 megabits, or 1,000 megabits? And the other mode is the duplex mode. Is it half duplex or full duplex? So you negotiate that with the switch. If and the switch will oblige accordingly. So if you are the NIC and you tell the switch, hey, I'm 100 megabits per second full duplex, then the port on the switch will change to 100 megabits full duplex, and you'll be okay. Okay. You can use the Linux or Unix EtherTool utility to allow you to view the changes settings. That's if you are connected to a Linux or a Unix network. Okay, now the Ethernet frame. So let's talk about that in details. The first thing you're going to have the preamble and the start of the frame delimiter. So let me see if I wrote that down. Well, I can tell here's what I want you to write. The preamble. So write preamble, and next to it, it's 7 bytes of alternating ones and zeros. I want you to write this down. The preamble, you can put dash next to it. It's 7 bytes of alternating ones and zeros. In other words, 0, 1, 0, 1, 0, 1, like 56 ones and zeros, right? Bits. The SFD, write this down also, is 1 byte. SFD stands for start of the frame delimiter. DELIMITER. The SFD is a 0, 6 ones, and a 0. So together, the preamble and the SFD, you have on, off 56 times, and then you get the SFD 0, 1, 1, 1, 1, 1, 0. This is to identify or to indicate this is the beginning of a frame, those two together. So they're not really part of the frame, and the only NICs that use it is the 10 megabits per second, by the way. The next is the destination address, destination MAC address. This is where you put remember when you do ARP? So here's what you do, by the way. This is where you put the destination MAC address. When the device sends you his MAC address, you take it and you stamp it right here. Okay? That's 6 bytes. That's 48 bits, right? Your source MAC address goes right here. That's also, you get that from the NIC. Write this down. The destination MAC address, you get it from the ARP. You stamp it right here. The source MAC address, which is also 6 bytes, you put it right here. You get that from your NIC. Right here is a 2-byte number called the type. This is to tell, write this down, the Ethernet type, to tell you what type of packet that's in here. So it'll give you a code to let you know what type of packet is inside this frame. This is right here, the data. The data is the layer 3 packet, right? The maximum packet size can be 1,500 bytes. The minimum is 46. I hope you're writing all this down, right? If the packet is less than 46 bytes, so what you do is you pad it. That's why you call it some padding if you needed it. You add some zeros till it comes up to 46. So if someone asked you, what is the minimum packet size that can be encapsulated in an Ethernet frame? The answer is 46. What's the maximum packet size that can fit into an Ethernet frame? And the answer is 1,500 bytes. Together, by the way, they are called MTUs, right? The message transmission unit. All right, so what's the frame check sequence? So what the FCS is, it stands for frame check sequence. It's a 4-byte number. And what I want you to write for that is, this is a code to check the integrity of the frame. To make sure, in other words, to make sure that when the frame reaches the destination, that the frame has not been tampered with or has not been corrupted. How do we do that, by the way? So before we send the frame, your frame, after it encapsulates it all the way up to here, not including the preamble and the SFD, you take from the destination MAC address all the way up to here, to the FCS, not including the FCS. You run it through a hash system and it comes up with a code. That code is stamped right here. Well, that code looks at the data, how it's set up, and comes up with a number, a hash number, and stamps it right here as the FCS. It's 4-byte. When you send the frame out and the guy receives it on the other end, he's going to run the same frame through the same hash, and the number comes up, you match it with what's stamped on the frame as the FCS. If it matches, that means the data has not been corrupted or tampered with. If it doesn't match, then the frame is no good, even if 1 bit is off. That means the numbers are going to be different. They're not going to match as the FCS, and then you drop the frame and you ask for another one, right? So this is the Ethernet frame, and when you transmit it, you start sending it from here. From here to here is called the header, and the FCS is called the trailer. So you start sending the data here bit by bit on the wire. If you are 100 megabit NIC, you start putting the data on the wire 100 million bits in 1 second. That's how fast you start putting the data in. All right? So that's your Ethernet frame. Troubleshooting NIC devices. Anything can go wrong with a NIC, of course. It could die. Some of the chip could be burned out. And sometimes they start, broadcasting like crazy. So make sure you have everything up to date in terms of NIC. The software is installed correctly. When you connect a cable to it, make sure there's a green light that is blinking. And if it says green, that means you are connected and you're good to go. All right. Now, here's something that I always tell my students whenever they go and start a new job. One of the first things that you could do, even if nobody is going to mentor you and show you around, you have something that you can go in with. What you want to do is you want to make sure that the network that you're going to be responsible for, you have a network diagram, the physical and the logical topology of the network. So make sure you write these 2 points down: the network diagram and the network mapping. You want to have the physical topology of your network. How are all the physical devices, routers, switches, the workstations, the servers, everything is physically connected together. Trace the wires and draw. If the company doesn't have that you starting your work with doesn't have it, well, you can actually draw a physical topology. You can use the program Visio, Vizio. I think we have that as part of what you can use part of our applications. So you can actually build a physical network and use the physical connections to show how everything is physically connected. And then use the logical connections, write the subnets where each network is located. If you can go down to each device and each workstation, each department, what they can and cannot access, what type of firewall settings, go through everything that you know. So when you go in on the job, on a new job, you want to have the logical and the physical topology on hand and look at it. They may take you a week or two learning all of this, but once you learn all of this, it'll be easier to troubleshoot. So if somebody goes wrong, you know exactly, where they are connected, which switch and which server they are connected to, what type of security they have, because you already learned that. You can easily figure out what the problem is. You can easily recommend on expanding, rechanging, finding out if there's any traffic problems, right? So learning, knowing the network diagram and physical topology and the logical meaning, how everything is connected, the IP addresses, even the MAC addresses of each device, what type of security is set on them, and so on. All right, so all of those are important when you are recording. Here's a typical physical topology that you can have, right? You can have the switch, the network, the firewall, and here's the file application servers that you can have, how they are all connected, wiring diagram. Here's a typical, I don't know if they used Visio doing this. This is the best way. This is the physical topology of a network, right? All the devices, how they are all connected, so you can do it nice and neat, and you can follow the cables, right? Physically, you want to follow. You can actually want to see how everything's connected and where they are. All right, so I think it was an easy chapter, if I'm not mistaken. So write down everything I told you, and we'll meet again in another chapter. So keep up with the homework, and I'll see you then.